Hello friends, let's do another partial fraction decomposition. We're going to figure out what the fractions initially were before these were added together. So what could have been, or what were the small fractions that were added together to create this larger, more complex rational expression. All right, so as we said before, we always want our fraction to be factored in the denominator. So this bottom part needs to be factored. And we need it factored into linear factors. And if you look at this, both of these factors, we've just got x to a first power and x to a first power. They're both linear. But what is unique about this compared to the others is that we have a repeated linear factor. We have two of those. So essentially what we have in the bottom is x plus 2, x plus 2, x minus 1. So we have a special way that we write this when we've got that unique situation, so that when we break this down, or we write it as a sum of partial fractions, I'm going to say a over x plus 2 plus b over x plus 2 squared plus c over x minus 1. So because I had that repeated factor, that squared, I wrote it once and then I wrote it twice. So if this had been, say, to the 5th power up there, we would say x plus 2, we would say x plus 2 squared, x plus 2 cubed, and we would go all the way up to x plus 2 to the 5th, right? So if that had been a 5, we would have 5 partial fractions written out. But of course, it's not, it's only a 2, so we don't need all of this, okay? But that was just to explain to you why we did what we did. So now I'm going to multiply everything by the LCD. And when I multiply by my LCD is x plus 2, x plus 2, x minus 1. And that's going to multiply by all of these terms. And in this situation, I have 4 terms. Don't forget that what we have on the left of the equation, the original part of the fraction, that is one of our terms. So doing that, and for space reasons, this might have to go on to 2 lines. I have 9 over x plus 2, x plus 2, x minus 1, and this guy's multiplied by x plus 2, x plus 2, x minus 1, equals a over x plus 2, again multiplying by x plus 2, x plus 2, x minus 1, plus b over x plus 2 quantity squared, x plus 2, x plus 2, x minus 1, and plus c over x minus 1, again times the LCD. X plus 2, x plus 2, x minus 1. And this creates a lot of canceling, which is what we wanted. So I'm going to lose all of the denominator in the first term. The second term, I lose 1 x plus 2. In my third term with the b, I'm actually losing both of those x plus 2's. And then on the c, I've lost an x minus 1. So I'm going to write this on one line now. I've got 9 equals a x plus 2, x minus 1, plus b, x minus 1, plus c, x plus 2, x plus 2. All right, so we started with that large fraction. We unadded it, and then we multiplied all of the terms by the LCD, and that caused some nice cancellation, so we were able to clear the fractions. So at this point, we need to solve this, and what we are interested in finding are my A, B, and C values. And I don't know what those are, but I can find them, and it's easy to find them if I use values that zero out each of the terms. So x equals -2 and x equals 1. But you'll notice we only have 2 values to choose here. So we're going to use these 2 values first, x equals -2 and x equals 1, and then we can choose any other value. There are different ways for us to do this. We're just solving a system of equations. So the first one I'll do is x equals -2. And what that leaves me with is 9 equals a, -2 plus 2, -2 minus 1, plus b, -2 minus 1, plus c, -2 plus 2, -2 plus 2. So this gives me 9 equals a times 0 times -3 plus b times -3 plus c times 0 times 0. And of course, we know what happens when we multiply by 0. Terms go away. So I have 9 equals -3b, and here I can see that my b value is going to equal -3. So that's one part of my answer. I have found b. And I'll do this again with x equals 1. So if I do it with x equals 1, I have 9 equals a, 1 plus 2, 1 minus 1, plus b, 1 minus 1, plus c, 1 plus 2, and 1 plus 2. So I have 9 equals a times 3 times 0 plus b times 0 plus c times 3 times 3. Again, the whole goal of this process was to zero some terms out. So zeroing those out, I end up with 9 equals 9c. And that can simplify. We know that c is now equal to +1. So we only have 2 values. And again, we need a, b, and c. So we can choose any other value we want to plug in. I could choose 1,000,000, I could choose 10, I could choose 17.9, but I'm going to choose a value that's nice and easy for us to deal with, and generally that value is +1 or 0. 0 is the easiest. So I'm going to pick to use x equals 0 in here. So plugging x equals 0 into this equation at the top of our screen, I'm going to have to scroll down. If I use x equals 0, there's a little smudge there. We have 9 equals a, 0 plus 2, 0 minus 1, plus b, 0 minus 1, plus c, 0 plus 2, 0 plus 2. So I've done the exact same thing, and this simplifies here. I end up with 9 equals A times 2 times -1 plus B times -1 plus C times 2 times 2, or 9 equals -2A minus B plus 4C. So I can't simplify this anymore right now. And remember, we're still looking for our A value. But I know a B and I know my C value. So I can plug both of those values in, and that's going to allow me to determine what A is. So B equals -3 and C equals +1. And if I do that, we have 9 equals -2A minus, again, B is -3 plus 4, C is +1. So now I have 9 equals -2A plus 3 plus 4, which is 7, and I can subtract that 7 from 9. 2 is -2A, and now I know that A equals -1. So I have all of the pieces I need, and at this point I can take what I originally started with and write it as this decomposition of partial fractions. So the fraction that I initially had, 9 over x plus 2 squared x minus 1, is now equal to my A value over x plus 2 plus my B value over x plus 2 squared plus my C value over x minus 1. So my A, B, and C values are going to plug in here. And because I know what those are, A being -1, I've got a -1. B was -3, so I'll write -3. And C was +1, so we've got +1. And so my final answer, my decomposition of partial fractions, are these 3 fractions I've just put in the box. And again, if we used some algebra to get common denominators and add the 3 fractions in the box together, they would simplify and give me what I started with, which is what's outside of the box on the left. 9 over x plus 2 quantity squared times x minus 1.